Hello, welcome to another lecture on communication research. Today we shall talk about the process of sampling. The sampling process comprises of several stages: defining the population, specifying the sampling unit, selection of the sampling method, and selection of the sample. Stages 1 and 2: defining the population and specifying the sampling unit. A researcher has to start by defining the population, which is the total number of items from which a sample is to be drawn. For example, if newspapers in a city are to be studied, the total number of newspapers in the city becomes a population, and each newspaper becomes a sampling unit. Similarly, if audience are to be studied, all media users in a city form our population, and each individual becomes our sampling unit. Since there is very rarely enough time or money to gather information from everyone or everything that forms the population, we make this process simple through sampling. Therefore, the goal of sampling is to identify a representative sample or subset from within the population which has the same characteristics as that of the population, or the results acquired from the sample. We shall be able to generalize those results upon the population. Sampling units in a way form the population. To identify the population, a researcher therefore has to define the sampling units. Now, stage 3: finding the right sampling method. The sampling method outlines the way in which the sampling units are to be selected. The choice of the sampling method is influenced by the objectives of the research, availability of financial resources, time constraints, the nature of the problem to be investigated. Sampling methods can be grouped under two distinct heads: probability sampling and non-probability sampling. These are also called sampling approaches, sampling techniques, or sampling procedures. Let's discuss probability sampling techniques first. Probability sampling is also known as random sampling or chance sampling. With this technique, the sample is taken in such a manner that each and every unit forming the population has an equal probability of falling into the sample. For example, if we are studying influence of media on audience and our population is the people living in a city, the probability sampling technique we may use will ensure that any of the thousands of residents of the city can become our sample without us hand-picking any individual. In this way, it is ensured that the sample truly represents the overall population. Probability sampling can be achieved by random selection of the sample among all the units of the population. The major random sampling procedures include simple random sampling, systematic random sampling, stratified random sampling, and cluster or multi-stage sampling. For simple random sampling, in order to get simple random sample, each member of the population is numbered. Then the size of the population, or the size of the sample actually, is drawn with the help of a random number chart or a lottery. Let's take an example to understand this. Say our population is comprised of 100 people and we have to pick a sample size of 10 people. What we will do is we will number all these 100 people from 1 to 100 and write these numbers on chits or pieces of paper. Then we put these chits into a container and pick any 10 ourselves or ask someone else to do it. It's the same way we do in the draw of lots, or we can use any similar way of picking the sample. The advantage of this method is that the sample will be free from bias because we really don't choose which of the chits to pick. And its disadvantage is because of its randomness, this simple random sampling technique can return us freak results that are not representative of the population. This problem can, however, be eradicated by increasing the sample size. In stratified random sampling, population can be divided into smaller, non-overlapping groups that represent the entire population together. And the sample is then drawn from each group separately and at random. Let's again take an example. A researcher looking to analyze the characteristics of people belonging to different annual income divisions will create strata or groups according to annual family income, such as he can have groups as high income group, middle income group, low income group, and very low income groups. For this, a predetermined criteria is followed. Then a random sample will be drawn from each of these groups. The sample size for each subgroup can be fixed to get a representative sample. This way it's possible that different categories in the population are fairly represented in the sample, which could have been left out otherwise in simple random sampling. Advantage of this technique is that it yields more accurate results than simple random sampling. Since it does not have any major disadvantages, this is one of the most commonly used techniques and most recommended techniques of sampling. Then we have cluster or multi-stage sampling technique. This resembles stratified random sampling procedure except that it has multiple stages. In some cases, the selection of sampling units may pass through various stages before we finally reach the sample of study. For this, a state, for example, may be divided into districts. Districts can further be divided into blocks. Blocks can further be divided into villages, and villages can further be divided into identifiable groups of people. And then random sample can be drawn from these groups of people that we have at the end. For example, taking random selection of 3 out of 15 districts of a state, 6 blocks from each selected district, 10 villages from each selected block, and 20 households from each selected village, which becomes a total of 3,600 respondents. This design is used when we have to do large-scale surveys which are spread over vast areas. The advantage of this technique is that it needs detailed sampling frame for selected clusters rather than having the entire target area. There are savings in travel cost and time in this technique, but there is a risk of missing on important subgroups and not having complete representation of the target population. When we apply this technique as compared to the other random sampling techniques or probability sampling techniques, what happens is since we go from a bigger group to a smaller group, the possibility of leaving out other groups is much higher, which is why it's not considered a genuine random sample. The sample we get in the end through this technique, through cluster or multi-stage sampling technique, is not considered a genuine random sample. Then we have systematic sampling. In systematic sampling, we first need to number the entire population. Then we choose a starting number, say number 5, and then we pick every fifth number of the population. This method has a predefined interval, which makes it the least time consuming sampling technique. Say we have to take a systematic sample of 500 people in a population of 5,000. Each element of the population will be numbered from 1 to 5,000, and every 10th individual will be chosen to be a part of the sample. We'll first pick 10, then afterwards we'll pick every 10th from among the 5,000 respondents or 5,000 people who form the population, and this way we will acquire the sample of 500 individuals. The advantage of this technique is that it can eliminate other sources of bias, but its disadvantage is that it can introduce bias where the pattern used for the sample coincides with the pattern in the population. That means while choosing the first number, a researcher can be biased to look for some pattern so that a particular trend in the population falls into the sample. In order to eliminate this risk, we can follow a simple formula for choosing the interval in systematic sample. The formula is n equals total population divided by the sample size. Say if our population, in the example we just took, if our population is 5000 and the required sample size is 500, our interval or n becomes equivalent to 5000 divided by 500, which is equal to 10, which means we pick every 10th sampling unit. This way we can eliminate the possibility of other biases coming into the research. The overall benefits of probability sampling is the bias in the sample derived from a population is negligible to non-existent. When the population is large and diverse, it's important to have adequate representation so that the data is not lopsided, and probability sampling achieves that. Probability sample helps the researcher plan and create an accurate sample. This helps to obtain well-defined data. Now we move to non-probability sampling. Non-probability sampling is any sampling method where some elements of the population have no chance of getting selected, while others might have a higher chance of getting selected into the sample. These elements which are left out are called out of coverage or undercovered elements. This method relies on a researcher's ability to select members at will or with purpose. There is no randomness at play, there is no probability at play, which means there is no equal opportunity among the elements of the population to constitute the sample. This method is not based on a fixed or a predefined process, as a result of which it is difficult for all sample units or elements of the population to have equal opportunities of inclusion in the study. It involves the selection of elements based on assumption regarding the population of interest, which forms the criteria for selection. Since the selection of elements is not random, non-probability sampling does not help in the estimation and elimination of sampling errors, which is one of the major problems with non-probability sampling techniques. And this is another way of saying that this technique has a higher possibility of inducing errors into the study. The kind of error we call sampling error, which is caused because of the problems in sampling. Non-probability sampling is a subjective method. There is no objective way of picking up the samples. It's a subjective method in which the selection of the sample or the sampling units depends on the personal judgment of the researcher or his own discretion or his own wishes. There is no method which is followed. The types of the techniques of non-probability sampling are convenience sampling, which can also be called opportunity, availability, haphazard, grab, or accidental sampling. Then we have quota sampling. Then we have judgment sampling, which is also called subjective or purposive sampling. And finally we have snowball sampling. Convenience sampling is dependent on the ease of access. This is the first type of non-probability sampling. It depends on the ease of access. It's based on how easy it is for a researcher to get in touch with the subjects, the subjects who form his population. Researchers have nearly no authority over selecting elements of the sample. It's purely done on the basis of proximity and convenience, and it's motivated by limitation of resources or sample units. That is, in convenience sampling, a sample population is selected because it's readily available and convenient. Quite obviously, the researcher using such a sample cannot scientifically make generalizations. The results acquired from the sample which is collected from this technique, the results cannot be generalized over the total population because we rely on convenience. Let's take an example to understand this. For example, we have an interviewer who is to conduct a survey at a shopping center early in the morning on a given day. Now, what does he do is he interviews all the people who come to the shopping center on that particular morning. But this practice is not repeated the next day or the another time. The probability of people who don't come to the shopping center at that particular hour is negligible. So the results acquired from this thing will not be, or this study we won't be able to talk about the other people who didn't become a part of the sample on the basis of this. This type of sampling is mostly used for doing pilot studies. A pilot test is a shorter form of the research conducted before the total research or the entire research process takes place, and the purpose of this is to create certain clarities very early on. If we are doing a pilot study, convenient sampling technique suits it. For example, this is an example of pilot study. If we are following a method in which we have to use a questionnaire, before drafting a questionnaire, a researcher can use this technique and conduct a pilot study using this technique in order to know the limitations of the target population. Once a pilot study is conducted, we have a better idea what type of questions to put into the questionnaire. The major disadvantages of this technique are: the population here is always unknown, the method for selecting cases is haphazard, and the cases studied probably don't represent any population. Then we have judgment or purposive sampling. What happens in judgmental or purposive sampling technique is the sampling is formed through the discretion of the researcher, purely considering the purpose of study along with the understanding of target audience. This is also called deliberate sampling or subjective sampling, because the participants are selected solely on the basis of researchers' requirements. Elements that do not suffice the purpose are not picked. Let's again take an example. If you need to know how coverage given by a news channel to an issue has created negative perceptions among audience, with this technique, the purposive sampling technique, you will identify a selected number of people who have been negatively influenced, without leaving any room in the sample for the people who might have got positively influenced or who might not have got influenced at all. So we are handpicking the people who have got negatively influenced. This sampling suffers from drawbacks of favoritism and nepotism. It does not give a representative sample of the population, as is the problem with most non-probability sampling techniques. As shall be clear, this type of sampling has a high possibility of inducing biases into the study. The results yielded by this technique cannot be generalized. I already said that. And this sampling method is seldom used and cannot be recommended for general use. However, if there is an experienced and a skilled researcher, he can draw valuable results using this technique. This technique is beneficial in that it does not let ambiguous data become a part of the study, because the data is literally handpicked. So the possibility of unwanted ambiguous data which can give us different results or create any possibility of yielding different results, we eliminate that possibility. Some of the purposive sampling strategies include extreme case sampling, maximum variation sampling, homogeneous sampling, typical case sampling, critical case sampling, chain sampling, and criterion sampling. These are all ways in which we acquire purposive samples. Then we have another type of non-probability sampling, which is called snowball sampling. Snowball sampling is used in studies where there is a need for us to there is a difficulty in reaching the different elements that form the population. For example, if we are studying nomads, it will be extremely challenging for us to survey them. Here, what a researcher does is he identifies one member of the population of interest and then speaks to him or interviews him, and then asks that one person to lead him to another person. Then that another person is interviewed or is given a questionnaire. Then that another person leads the researcher to another person, and so on. So hence the term snowball sampling. It's used in conditions in which the defined population from which the sample is to be drawn is not available. Therefore, the process of sampling has to depend on the chain of referrals. The advantage of these systems are small sample size. It has a small sample size because it's difficult to reach the sampling units, and it has a very low cost. But the bias and lack of diversity in the sample are its big disadvantages. A sample drawn through this technique will not represent a cross section of the population. As I said, this is the common disadvantage of all non-probability sampling techniques.